Terminal velocity, highest velocity attainable by a falling object. For other uses, see terminal velocity disambiguation. Terminal velocity is the maximum velocity speed attainable by an object as it falls through a fluid. Air is the most common example. It occurs when the sum of the drag force and the buoyancy is equal to the downward force of gravity acting on the object. Since the net force on the object is zero, the object has a zero acceleration. This is force Fd, this is Fg. The downward force of gravity Fg equals to the restraining force of drag force Fd. So we can say that upward force is Ft and downward force, which is actually the force of earth or the force of gravitation which attracts anybody about towards itself, it is Fg plus the buoyancy. The net force on the object is zero and the result is that the velocity of the object remains constant. In fluid dynamics, an object is moving at its terminal velocity if its speed is resultant due to the restraining force exerted by the fluid through which it is moving. As the speed of an object increases, so does the drag force acting on it, which also depends on the substance it is passing through, for example, air or water. At some speed, the drag or force of resistance will equal to the gravitational pull on the object. At this point, the object stops accelerating and continues falling at a constant speed, called the terminal velocity, also called settling velocity, an object moving downward faster than the terminal velocity.